Okay, so we're talking about arithmetic series, which should signify that there's a connection to arithmetic sequences. Hello. And so we just need to discuss what's the difference between a sequence and a series. An example of an arithmetic series is 1, 4, 7, 10, 13. Right? We have a first term of 1 and a common difference of 3. And you add the common difference every single time. That is a sequence. What a series would be is you take that sequence and you add up 1 plus 4 plus 7 plus 10 plus 13. What is that? 5? 35. And what we're going to say is that that is the sum of the first 5 terms of that arithmetic series. Okay, we use a capital S because it's a sum. And it's the first 5 terms. 1, 2, 3, 4, 5. So that is the sum of a finite series. Okay, finite just meaning you're summing the first certain number of terms. We will talk about infinite series at some point. Today they're not applicable because you cannot really add up the sum of an infinite arithmetic series because the numbers just continually get a larger absolute value. They would go to either positive infinity or negative infinity. But that is the basic idea of what a series is. So, like the rest of the chapter up to this point, this section has formulas. All right, this one specific formula here. So, the sum, and again we call it Sn, where n is the number of terms. The sum of the first n terms of an arithmetic series is given by this formula right here. Sn is n over 2 times a1 plus an, where a1 is the first term, an is the nth term, and n is the number of terms. So we are going to be using this formula right here a lot. Okay? To the point that once you've gone through today and you've done the homework and stuff, this is one that most of you will probably have memorized without even trying to memorize it. You'll have just used it so much. We have that formula. What is the sum of the finite arithmetic series 14 plus 17 plus 20 plus 23 plus ... plus 116? Our formula for the sum of a finite arithmetic series is this. The sum of the first n terms is the number of terms divided by 2 times the first term plus the nth term. Here, we are given the first term is what? 14. The nth term is 116. How many terms are there? We have to figure it out, right? There's a ... here. We have to figure out how many terms there are. How are we going to do that? We're going to use the formula we have for the nth term of a geometric sequence, which was this one. The nth term is the first term plus n minus 1 times the common difference. In that formula, we know that the nth term is 116. We know that the first term is 14. We do not know n, that's what we're trying to solve, but we know that the common difference is 3. We get all of that from up here. So subtract 14 from each side, we get 102 is 3n minus 3. 105 is 3n, so n is 35. So what we found out is that in this series, 116 is the 35th term. Now, up here, we want the sum of the first, now that we know, 35 terms. So we know n is 35, we know a1 is 14, and we know that an, which is now we know a35, is 116. So the sum of the first 35 terms is 35 over 2 times 14 plus 116, which is what? It should be 2,275. So it is just a matter of plugging into a formula, but occasionally you may have to solve for one of the pieces of information that you need to plug into the formula. There are 30 rows of seats in a large arena. The first row contains 10 seats. Each successive row increases by 3 seats. How many seats are in the last row? How many seats are there in all? So this is asking 2 questions. The first question is an arithmetic sequence question. They're asking how many seats are there just in the last row. So take your sequence out, and what's that last term? The second question is a series question. If you take that sequence that you got, add them all together, what's the total? So, we know here there are 30 rows of seats. So n is 30. We know the first row has 10. We know that the common difference is 3. So what do we do to answer the first question? How many seats are in the last row? The first question, how many seats are in the last row, they're asking for the 30th term in the sequence. The 30th term is given by the first term plus 30 minus 1 times d. So how many seats are there in that last row? 97. So that's the first question. How many seats are in the last row? 97. How many seats in total? So add up the number of seats in the first row plus the number of seats in the second row plus the number of seats in the third row all the way to the 30th row. So they're asking for the sum of the first 30 terms, which is 30 over 2 times the first term, how many seats there are in the first row, plus the 30th term, how many seats there are in the last row. So at that point it should make sense why they asked us to get this first. All right, we had to have this number to plug into this formula. So this is going to give us the sum of the first 30 terms. It's going to give us the total number of seats in the theater. And how many seats are there? 1,605. So there are 1,605 seats in the theater. That's what we found out. Sigma notation. Okay? This is a series, and so we are adding things up. So we use the Greek letter sigma because it's an S, and it means sum, right? So the sum as n, so we're going to have numbers above and below the sigma. So in the example they have here, n goes from 3 to 108 of n squared. The problem we just did, we took the sum as n went from 1 to 30 in the theater example we just did, because we started with the first term, the first row, and we added all the way up until the 30th row. And then what you have to put here is what you're summing. So you're adding up the terms from the first term to the 30th term of what? And this is where you would have to put your formula for your series. And ours, using the explicit definition for a geometric sequence, was 10 plus n minus 1 times 3. And when you see problems like this, they are usually going to give this formula in simplified form, meaning you distribute this 3 through, and so that's going to be the sum as n goes from 1 to 30 of, what is that, 3n plus 7? So this is the theater problem we just did. If you are given this, and you're asked for that sum, what do? Plug in 1 here. Because we remember that our formula for the sum of the first, in this case we know it's 30 terms. Because we know we're going from 1 to 30. The sum of the first 30 terms is 30 over 2 times the first term plus the 30th term. How do we figure out the first term? Plug 1 in for n. We get 3 plus 7, which is 10. How do we figure out the 30th term? Plug 30 in here. 3 times 30 is 90, plus 7 is 97. So we're going to have 30 over 2 times 10 plus 97. And we get the same answer we had before, which was what? 1,605. How many terms are we dealing with here? As n goes from 3 to 108. 106. There are 106 terms there. You always do, and look at this example. What's 30 minus 1? 29. But we know there are 30 terms here, right? To get the number of terms, always do the top number minus the bottom number plus 1. So 30 minus 1 plus 1 is 30. 108 minus 3 is 105. Plus 1 is 106. You're dealing with 106 terms here. And again, to get the first term, plug in 3. Last term, plug in 108. So, here, part A. All they're asking us to do is to rewrite that series in sigma notation. They're not asking us to actually evaluate the series. So to write it in sigma notation, we need to know how many terms there are, and we need to know the explicit formula for the sequence. So we know the first term is negative 19. We know the common difference is 5. So the explicit formula, an, is negative 19 plus n minus 1 times 5, which if we simplify, we get 5n minus 24. So we need to know how many terms there are. So I need to know 226 is what term in this sequence. So set 226 equal to 5n minus 24. And we find that it is the 50th term. Everybody with me there? So then what is the sigma notation? It is the sum as n goes from 1 to 50 of 5n minus 24. And again, in this example, they're not asking us what is that sum. They just asked us to write it in summation notation, which is what they call it, summation notation. I will probably refer to it as sigma notation, the notation involving the Greek letter sigma, so those of you that are taking Greek have an advantage. Part B. We know the first term is 20. We know the common difference is negative 2. So the explicit formula, 20 plus n minus 1 times negative 2, which if we simplify, we get negative 2n plus 22. This series goes all the way until negative 26. So what term in this sequence is negative 26? It is the 24th term. So then the sigma notation, the sum as n goes from 1 to 24 of negative 2n plus 22. Let's just do parts A and C. So part A. Part A is fairly straightforward. How many terms are there if we go from 1 to 27? 27. 27 minus 1 plus 1. What is the first term? The first term is you plug in 1 for n, which is negative 1. What is the 27th term? You plug in 27 for n, which is what, negative 53?
Yeah.
Negative 53. And then you use our formula. The sum of the first 27 terms is 27 over 2 times the first term plus the last term, which is what? Negative 729. So in part C, how many terms do we have? 6. 5 minus 0 plus 1. 6 terms. And so for this one, what we want is 10 to the 0 plus 10 to the first plus 10 squared plus 10 cubed plus 10 to the fourth plus 10 to the fifth. They're messing with our minds a little bit here, but that is 1, 1, 1, 1, 1, 1. Right? 1 plus 10 plus 100 plus 1,000 plus 10,000 plus 100,000. All that series does is it puts a 1 in every single spot. It's 111,111. But I wanted to look at how do you count up how many terms there are in sigma notation. Top number minus the bottom number plus 1. Every single time. Top minus bottom plus 1. That is how you count it up. 223,210. So yes, this is something some of you, your calculator makes life much easier for you with sigma notation. Those of you that don't have that, sorry.